This paper was presented at the JCT Traffic Signal Symposium 2025. Video coverage of this paper is provided by Highways News and sponsored by Mobius Networks, AGD, Smart Micro UK, TRL Software, Traffic Group Signals, AD Electronics, and Four-Way Consulting.
Yes, I am here today to tell your story, as it says there. You will notice that says two people up there. Unfortunately, Gareth's not here today. But what he has done is he has sent us a message. So
everyone, my name is Gareth Jenkins and I'm Principal Engineer for Swansea Council. And I was meant to be presenting alongside Mark today. Unfortunately, instead, I'll be travelling to Tuscany for a holiday. Yes, I know I drew the short straw, but I will manage somehow. I hope you all enjoy our presentation on the Swansea Bay and West Wales Metro, a project Mark and I are both very proud of, and we hope you find it interesting as well. Lastly, I must apologise in advance for Mark's enthusiastic but poor pronunciation of Welsh road names. After 24 months, we were hoping for some improvements, but this never happened. I'll now leave you in Mark's capable hands. Diolch yn fawr.
Excellent. Right, okay, so yeah, he's right. I'm really terrible at Welsh. I'm better at Spanish, so if anyone got any work in Benidorm, I'm up for that, okay? Right, okay, let's look at project overview. So we need to do, we looked at a strategic and technical development. So we're just looking at the Swansea Bay area and West Wales in general. The focus is obviously implementing better bus priority. It's part of the larger package. We were just specifically looking at the traffic signal technology point, but it's a larger package. And it's not just Swansea we're looking at. It was beyond that, is Talbot, there was Carmarthenshire, Pembrokeshire. I can pronounce them, so that's all right. They're not too tricky, those ones. Okay. What is the Wales Metro? If there's anyone in from Wales here, you might already know this. So it's about Transport for Wales. It's their initiative, a bit like we've got in England. It's all about improving bus journey, not just journey time, sorry, it's a bus user experience. That's what I really need to get used to, because I think a lot of people talk about bus priority. It's bus user priority now, which I'll cover a bit more as we go on. We want to look at getting modal shift, green ways of travelling, and improving connectivity between the different types of sustainable travel, okay? This is TFW's vision. I'm not going to go into it too much. This is what's on their website, kind of a bit more detail on what I've just said, and it does go on a bit further, but I'm not going to, I'll let you read that at some point. What is specifically about the Swansea Bay and the West Wales Metro? So that's obviously TFW. TFW got this larger scale across the whole of Wales. This is what's happening within Swansea Bay area. So we've got the regional map here. As we say, it's West Wales, so it covers the blue areas, as you can see on the map, cover what's really being looked at. We've got the yellow lines that talk about the rail connectivity and getting that together. Then we break that down further. This is the Swansea Bay area that we've been looking at, and then it breaks down even further with the, I'm not even going to pronounce the Welsh word, but it's the Welsh Clipper, basically. And they're all the bus routes that are going in and out of Swansea, and this is what we started to look at, okay? We also need to make sure we're doing a transition from the old legacy systems and using more of the advanced modern technologies that are available. So the legacy system itself, what's the problem with it? So the previous bus priority system was, it was the on-bus tagging system, originally deployed in the early 2000s, I think it was. Had to be on the bus themselves. I see quite an old bus there. I don't think they're using those buses in Swansea, but I thought I'd have a nice picture. Okay, it's long been obsolete. It's not really being used for anymore. So we've got an increasing need for modern technologies, which is what we're basing this a lot on. So our methodology for this is based on LTN 124. So hopefully everyone's read that. It came out last year. And we're from that, we've put together a 7-point process. As you can see, nice 7 points. So the first one is looking at a corridor at a time. So it's looking at the bigger picture. Where are the delays? What can we do from this? We then start breaking it down to the next two, which is about reviewing existing conditions. How can they be improved? And then really drilling down some slightly kind of more detailed situations. Once we completely understand the problem, we then start looking at solutions. Okay, so first of all, it's the solutions that are going to be directly improving bus journey times, reliability, and bits and pieces like that. It's then looking at non-direct bits and pieces. So that could be modal shift, removing cars, any friction away from the bus journeys themselves. And then the last one is consideration for other benefits. So that could be, that's including mobility hubs. So you could have people who can then get from nearby routes, nearby areas that not on bus routes, and you can have mobility hubs so they can bring their bikes on and then get on the buses, looking at active travel as well. But it must be in a situation where it's not going to affect the main objective, okay? And then the last one we've got is a selection of solutions to be taken forward. When we do the selection, it's not just about cost, it's also about time, inconvenience, and the most important one at the moment, which I think is environmental impact. That's a massive contribution. You've really got to think about the environmental impact now in what we do. So this is the roadmap, and pun is definitely intended on this one. And this just shows you how we get to each of these points, okay? So what do we do for the design process? So the design process was done in 2 stages, and this was actually accidental. We set out to do it in one go, one lot of design, and that was, we had to look at local detection. For those who have read LTM 124, you'll see it is recommended to use AVL because it's a lot easier to use and it's a lot cheaper. The problem we had in Swansea was the bus companies were not playing nice. We couldn't get AVL data, but they still wanted obviously some of this bus priority across the corridors. So we designed it in that way, and we had just started, we'd bought, well, Swansea had purchased all the equipment and paid for the installation, and we were getting ready to install, and then the bus company suddenly said, we can give you the data. So we then went through a second phase, why the local stuff was being implemented, and started at AVL, because it is that easy to add AVL. If you've got your proper UTMC, UTC system in place, and your comms are there, it's quite easy to add the AVL data in. So first of all, we'll look at stage 1 design. So what did we do? After we're doing some research, we spoke to the client and various equipment manufacturers. We went with RTEM, inductive loops with RTEM detection equipment. Yeah, that was preferred at the end. So, but we did use AI video detection where loops were not suitable or economical, and various bits and pieces like that. Placement loops or detection zones are ideally 8 to 10 seconds. Obviously that very much depends on the speed of the road and what else is going on. And then we was given bus priority was applied using priority mode within the controller or priority within mover. We have some sites that were right in the city centre which are UTC based, so it used priority through there. Next one we got is, so then we moved on to stage 2, the addition of AVL. Again, virtual detection points were set at 8 to 10 seconds. Obviously with the virtual detection points, the bonus part of that is they can be removed very, very easily. Okay, so we was applying AVL to local control sites. So once upon a time, AVL was all about in UTC. The way it is now, as long as you've got UTC comms or you've got the comms through there, it can be just sent onto the controller and local control can use that data and do something with it. So we had also looked at AVL linking. So within the city centre with some sites that are quite close. So through the AVL, we had better linking and created like mini green waves through certain sites. And then we also had to consider of how to switch, auto switch between local bus priority and AVL and vice versa. Our main aim is for the AVL data to work, and then if there is a problem, it was able to switch down to the local if needed. So this is where I do my horrible pronunciation of forest thatch, and I'm sure that's wrong, but I get picked up on it every time. So this is one of the junctions we looked at. So this is a nice busy crossroads we've got here, and so what we've done here, we're going to concentrate on that particular arm, just to show you some examples of what we was doing. So from here, that is that arm. As you can see, we've used RTEM loops there, so the double loops, but we've also doubled up on using them for the in loops for the mover. So we installed mover here as well, so we've got double whammy there. We've then added in the AVL back further, because that can pick up bus routes, so you can put them a bit further and not worry about the right turn where the buses are not going. And then just to add a bit more flair in there, we decided to use AGD 650s for the stop line loops here to save us cutting more loops. So implementation, how did we do about that? So we had a coordinated approach with ourselves, Swansea and Swaco, who's the main installers. We had a configuration of the bus priority was a little bit trial and error with some of it, because we was trying to doing stuff a little bit different, especially the switch between the 2 different types where needed. So yeah, that took a little bit of it. Once we got it right on 1 or 2 sites, we could then use that in the special condition that we was using and put it on others where appropriate. We then had to refine the detectors to ensure the buses were detected correctly and at the required point. So there was a few kind of changes, especially obviously the R10 once they're on, the loops are in, the loops are in, but those all seemed to be okay. It was more the AI stuff and the video detection. And then we had to do the validation of the bus priority and the mover. So some nice pictures there just quickly. The 650, obviously you can see low down because it only does kind of closely detection points. The FLIR on the very high pole to get the distance, and then the R10. Just a quick slide just showing you how the 650s work. So we did use them for bus priority. The reason why we've used them, as you can probably see in the very top right-hand corner, you can see a bus lay-by. So we had to bring the detection in a bit nearer. As you can see there, car not activating, cycle not activating, bus on the inside, bus on the outside. It was working lovely. This one's a FLIR. Like I just said, we did put them on tall poles so you can get nice down the road along detection. But this one was quite a weird, complicated junction. So we needed somewhere where we can kind of draw in the different and test the different types of detection zones that we wanted. I've got a yellow light, so I'm going to try and speed up. Okay, monitoring the journey time. Okay, so we monitor in term using bus Bluetooth journey data. And this was the corridor or down there. This was analysed on the AM peaks and the PM peaks for a 2-month period before and after we put in the local detection. These are the results. As you can see, they're pretty good. The only thing I'd say is there is a bit of a weird one on the PM on the westbound. It says 13 seconds actually made it worse. We're trying to figure that out whether that's a glitch, but we do think it's because there's quite a few buses across going through a certain junction that's actually causing more delays. So that's something to watch out for. You might put bus priority on, but if it's going to cause delays and actually do a negative effect, we are looking at that, and we'd also think that that would be cleared up once we get AVL active, because that could be more selective. Another part of the monitoring we're doing, we were working with R10 to break it down. Because of the journey time data looks at the whole corridor, we were using the R10 card, so it would look at when the controller received a bus input, what the controller did by looking at the control mode it was in and whether it changed, and then there's a detector on the exit that says did it get through, and that all collects up on the R10 server, and then we can see in individual sites what's happened with the bus priority, not just looking at the journey time, and then we can see if it's actually working or not. Right, so in conclusion, okay, so the primary aim with this is to improve the overall, or help improve the overall best user experience by speeding the bus up and looking at reliability and getting the buses through, reducing the friction basically. And, oh, sorry, gone backwards then. What's happened there? There you go. And while it's not yet fully implemented, the results are looking really promising at the moment on the local stuff. And hopefully next year we can come back with the AVL and bits and pieces. And while the deployment of both AVL and local may seem a bit overkill to some people, it was a bit accidental. The money was already there, and it's allowed us to actually see the difference between local and AVL and the ability to be able to switch between the two if need be. So there's always going to be bus priority there. Okay, so yeah, and obviously you can use AVL, use a UTC. I know we have some of these sites are quite rural, and they either you lose the GPS coordinates from the bus itself, so they're not getting the data, or they actually lose the comms themselves. So it was good, at least some of everything's going to get a bit of data. Right, I'm still on yellow, so I'm not quite red yet. But anyway, I just want to say thank you to these people that is involved. So we've got the guys from Swansea, we've got some guys from Swaco. Paul Rouse has really been helpful with the configurations we've been doing to get around some of the bugs that are in certain controllers to make sure we work. I've got Anap, I don't know if he's in the audience, he's probably still next door, who we've worked with getting the detection and monitoring system set up, and my team who has obviously been helping with the design and the implementation. And then I'm going to go any questions.
Well done, Mark.
Thank you.
OK, we've got one down here, please. Obviously a young new face, I don't recognise you. So
I played LPTC. Thank you, Alistair. Sarcasm appreciated. Mark, I think it's simple. From what you've said, you're prioritising every bus. You're not selecting buses that are off timetable or according to occupancy or maybe a few words?
For the local, yes, that's all it can be. It can be It's all or nothing, and that's what we was originally set with. And then when we've finally got the bus company on board to use the AVL, we'll decide whether it needs to be late, certain routes, whatever's going on, and that will be selected. That's why we can be so much more selective with AVL data.
Thank you.
So.
Okay, another one in the middle here.
Zach Mabs, ATE. With a new scheme coming ahead, would you still reckon that the AVL and local detection in parallel is worthwhile? Or is it just, as you say, a lucky coincidence?
No,
Cool.
that is my honest answer. AVL is because it's a lot cheaper, a lot easier to implement, a lot easier to play around with. So yes, like I say, it's only because this was accidental. It was already paid for. They couldn't kind of go back to the manufacturer and say, "Have kit, can we have the money back?" Can't refund it. And we've already put it into action. It was just like I say, Gareth would probably be the better person to answer that question because he was in charge of it. Also, it was a decision made saying it's already paid for. Let's see what happens and what we can get out of it. So majority, in the end, it's majority going to be AVL, and that's what I'd recommend in general. So
Good. Any questions from the balcony? No. Any more? Oh, one more. Last one.
Hi, Neil Reeds, TRL. Just a quick one. In terms of the bus company changing their mind, I guess, what was sort of drove their change of heart, and how could other people avoid that situation?
again, that was dealt with Gareth. That's why I need Gareth here. I'll keep pointing here. He's not here. I don't know. It was very much of they tried talking and talking and talking. I think a lot of it is, I don't know if there was something political that had changed over the year, because it was about just over a year, and then they suddenly went, okay, we'll supply you with the data. So I don't know if something political was happening or they'd managed to convince them that it's worth giving the data. I don't know the full details of that because we didn't get privy to it all, but it was just suddenly nice to go, you've got the data. It's like, great, okay, we'll use it now. So.
Brilliant. Okay, so thank you, Mark. Thank you.